Part A of this problem says find the coordinates for all critical points, which means we're going to have to find the derivative because critical points are defined as where the slope is equal to 0. So we are going to first find f prime x, which seems like it's going to be quite fun because we are going to do 2/3 times 12 times x to the negative 1/3, because in our power rule we're going to subtract 1 from our exponent, okay, minus the derivative of 4x is 4. So then we have f prime x equals 12 times 2/3 is going to be 8, because we can take our 12 and our 3 and cancel it to 4. So we get 2 times 4 is 8, or you could say it's 24 over 3. And it's going to be over the cube root of x, because we have x to the negative 1/3, and then minus 4. Okay, I should also mention that critical points occur when the derivative is undefined. So we can see that there's going to be at least one x value where that happens. So now we need to set this equal to 0. Okay, so we say 8 over the cube root of x. That kind of looks like 3 times square root x. The cube root of x minus 4 equals 0. So 8 over the cube root of x equals 4. Okay, so then we have 8 equals 4 times the cube root of x. And then we have 2 equals cube root of x, because we're going to divide that 4 over. And then we just have to cube both sides, so we get that x equals 8. So the derivative is 0 when x is equal to 8, and that's one of our critical points. Now, I should point out that once you're like right here, you could decide you're going to eyeball this solution, because you know that this piece needs to be 4. So you know this piece needs to be 8 divided by 2. So then if you know it needs to be divided by 2, then that could tell you, well, this needs to be cube root of 8 then. But you can always just do all the algebra all the way through to get to it. Okay, so that's one of the critical points. Now, where is it undefined? Where is it undefined? Well, 8 divided by cube root 0 is going to provide an undefined slope, because it's going to make us divide by 0. So that means that x equals 0 is also a critical point. So that is all of our work for part A. X equals 0 and x equals 8. Now we need to determine if they are extrema or not. So we need to make a table where we are going from negative infinity until our first critical point of 0. And then we go from 0 until our second critical point. And then now we have no more critical points left, so we're going to go 8 to infinity. And we're going to look at the sign of f prime x and use that to describe the behavior of f of x. So our original function was 8 over cube root, or sorry, that's the derivative. It's oh yeah, but we want to look at the derivative. 8 over cube root x minus 4 is our derivative. F prime is 8 over cube root x minus 4. Okay, so to determine what this sign starts as, we should plug in a number on this interval. So let's use negative 1, easy number that's close to 0. So f prime negative 1 equals 8 over the cube root of negative 1 minus 4. So that's going to be 8 divided by negative 1 is negative 8 minus 4, which is negative 12. So the derivative starts as being negative, which means f starts by decreasing. So we picked x equals negative 1 in this interval. So now maybe we can pick x equals 1 and the next interval and see what happens there. So now we can do f prime 1, and that's going to be equal to 8 over the cube root of 1 minus 4, which is going to be equal to 8 minus 4, which is equal to 4, which is positive. So we now have a positive value. So now we're increasing. Now let's pick a number from 8 to infinity. Let's just pick 9. So we picked x equals 1 over here. X equals 9. So last one, we'll do f prime 9. This one's going to be a little bit tricky. You know what? So because this is a cube root, let's go ahead and pick a perfect cube. So our perfect cubes are 1, and then 2 cubed is 8, and then 3 cubed is 27. So let's go ahead and use x equals 27 instead, so that this is an easier calculation to do. F prime 27 equals 8 over the cube root of 27 minus 4. So what does that equal to? That is 8 divided by 3 minus 4. So this is actually going to be negative because 8 over 3 is going to be smaller than 4. Because what is 4? 4 would be 12 over 3, right? So that means that 8 over 3 is smaller than 4. And we have a negative output, which means we are now decreasing again. So then that implies that x equals 0 is a min because f prime switches from negative to positive. And we'll say x equals 8 is a max because f prime x switches positive to negative. Okay, so those are our two critical points. They are both extrema. One is a min and one is a max, and we have to write this justification down. We can't just do the table. We have to actually write this confirmation down here. What's happening when we have an undefined slope? It's so it's a minimum. It's probably something like this where it comes down to a point and then keeps going up. Okay, the slope is undefined here because you could have multiple tangent lines, but it's still a minimum value because on either side values are bigger than this value. It's the smallest value in its area. But the slope is undefined because if you plug in x equals 0, you get an undefined slope. So that's what's going on there. And then we hit some kind of maximum at x equals 8 and then keep decreasing after that. Okay, so now we're going to find all the coordinates of the points of inflection, which means we're going to have to take a second derivative. You know what? I'm going to do that in a separate video since this is getting kind of long.